Hello, everyone, and welcome to the next episode of our Autodesk Inventor creation series. As you can see, we're back on this document that we had from our last episode, and we're going to be going into a few more details on how these projects work. So last time, I did something that was a bit odd, and for some reason deleted these baselines. So I'm going to go ahead and re-add those really quick. In case you've forgotten, all we're going to do is go to Annotate, Dimensions, and then in Dimensions, we're going to go to Baseline here. We also have other options like Ordinate. These are essentially just going to make sure that dimensions align, and then Chain. I will just create essentially a running chain of items. These can be used to whatever you like. Ultimately, all of these are just different ways of presenting information. Some of these are aligned, some of these are in ascending order, and some of these are just lined up. Whatever case you need, we're going to demonstrate these. So Ordinate would simply be, oh, got to select the drawing first. Then what we can do is just go ahead and zoom in. As you can see, we'll just be selecting, selecting these features here. All right, there we are there. There we are there. There we are there. There we are there. And all you need to do to finish any of these options is to right click. I said right click. There we are, and hit continue. And as you can see, that is now going to create these ordinate dimensions that essentially will tell us this point here is our origin. And if I were to line these up, I could also do it this way, but I'm going to do it this way, where essentially this point is our origin. And as you can see, this is going to tell us our distance from this point. Now, that's a bit harder to see because you don't have those nice lines there. So I'm going to do it in the baseline form. Chain form would essentially just be the same thing, where you have this, 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 and this will, as you would expect, if I right click and hit continue, that is going to create a running chain of these objects here. All right, now I'll actually go ahead and leave that there. This is a form to demonstrate. And so generally speaking, what options are you going to use? Well, ultimately what you want to do is make sure that you use things that are going to give you information in your actual manufacturing process. So for example, if I were to Control Z this and go back to the ornate form, to the second option here, the ordinate form, that would have my 2.25 dimension here, a 0.5 dimension here, and another 2.25 dimension here. Here's the problem though. This item is, let's say this item was a 3D printed and let's say cut out of a block. Now the problem is that the first thing I'm going to do most likely is cut my disc to be this thickness here, the thickness between these two items, the very top and the very bottom. And then I would most likely round off these corners and create this disc, just a flat disc that is of this diameter. And so these 2.25s aren't really helpful information because I have to go through and add these items up. And the fact of the matter is that that's going to add error. That's going to add error to our design. And that's something that we definitely don't want. You want this design to be as accurate as possible. So every time you add a new dimension to this equation, all of a sudden you're adding new information that is going to increase your margin of error. Think of it this way. If I have a line that I want to make into a meter, if you see me on camera right now, let's say that the distance from my two fingers is 1 meter long. Oh, there we go. Let's say that I want to measure 1 meter. The best way to measure 1 meter will most likely to get a meter stick or a ruler and then measure the distance from this finger to this finger. However, if I go ahead and decide to measure the distance between these two, let's say I measure to a point here, right? Let's say I measure to this point over here where my pinky is. So I'll measure from here to where my pinky is and then measure the distance from my pinky to this finger over here. The problem is that extra step is introducing a margin of error because I may or may not have measured this distance exactly. I might have measured this to about 1/10 of a meter, or maybe probably most likely that's going to be a centimeter, probably 0.1 centimeters in terms of my accuracy there. So that's going to introduce a higher margin of error as opposed to just measuring directly. And so what I want to do is make sure that I have a lot of these base dimensions indicated. And so the best way to do that is usually through baseline. But again, you can just go click the actual dimension tool, just go to dimension, and then you can add them yourself. So I'm going to go ahead and re-add all of these baseline dimensions here. And that's going to determine the distance of this stuff from this baseline over here. And as you can see, now I have the diameter of the diameter of my disk. Then I also have the distance from here to here, as well as the distance of the center area to here. If I were to cut this out of wood, most likely not wood, out of aluminum, probably 6061 aluminum, what would actually happen is I would put this disc on a lathe and I would chip away this exterior here. And so it would be very important for me to know how far in I need to go with a tool on the lathe to cut away 2.25 inches of this material. So keep in mind that if you're someone who's going to manufacture this, unless this is being 3D printed, chances are you want to be very specific about how you have these items done and labeled. Now, if you're going to 3D print this, ultimately the computer generates all that information. You already have everything you need if you have an STL file of this. So that's not going to be that important. And you can, obviously it's still good to have these habits, but you're going to want to make sure that you have all the information that would be important to manufacture anyway, just as a good force of habit. So anyway, I don't know why I deleted these baseline dimensions, but one of the things I wanted to show was that this dimension here is not that useful, the 2.75 dimension. I already know that I'm going to cut in here 2.25 inches, and so I could deduce that if this is going in a circle, as it would be on a lathe, chances are that this side is also going to be 2.25 inches already. So I don't really need that. So here's what I'm going to do. I'm going to go hit, oh, I don't know what happened there. I'm going to go ahead and pause. Sorry, I don't know why my dimensions kept on disappearing. I have no idea. So nonetheless, I was able to get them all in here. This dimension isn't all that important, so I'm going to get rid of it. And chances are that that information might be a bit more relevant over here. So I might want to add this information here. One of the things that you notice is that this actually is, it's a dotted line, not a solid line. This means that this view is upside down so that the bearing, the little bushing is on the other side. That's not really that important, but I'm going to go ahead and flip it anyway. I'm going to edit the view. And what I'm going to do is just use this little cube there to rotate it around, hit OK. And now, as you can see, yep, that should be fine. Oh, that flipped my other view upside down. That should be fine as well. All right, so now I have this on the top. I'm just going to go ahead and add my dimensions. Again, I can simply arrange or import or retrieve the information that I have, but I'm just going to go ahead and add this stuff manually because it isn't all that much. So this is 0.5 inches. Diameter here. This is a bit redundant information. It's okay to add this information simply because, again, if someone is using a different method to do this, maybe someone is gluing this piece in afterwards, even though I highly wouldn't recommend that. Just, you never really know how the manufacturing process is going to go for sure. So you just want to make sure that you have that information down. All right, I'm also going to give the thickness of this spoke. And I'm also going to give the radius of this fillet. I said the radius of this fillet. Oh, that didn't work. Sorry. Go here and get the radius of this fillet. There we are. All right, our radius of 0.13 inches. So again, that's not very accurate. I should actually increase my accuracy to 3 decimal places. But again, that also depends on your manufacturing process. You're going to add tolerances, which we'll talk about in a second. But one of the things that I also wanted to touch on is you should technically be adding one of these radii to every single one of these corners, as well as one of these thicknesses to every single one of these of these small spokes. But you don't really want to be doing that. So instead, what you can do actually is I'm going to go here, and there are multiple ways that you can add this information. Essentially, what I'm going to do is do this. You can add precisions and tolerances here. So for example, I can add the precision here, and that's going to increase my precision. And the second thing that I can do is, if I go to the text, and I'm going to go ahead and add is, I'm actually going to go import this 6 times. Hit OK. And it's going to say 6 times 0.125. Now, this is going to be seem a little bit confusing, but essentially what that tells us is that all 6 of these, you can read that there are 6 of these items. That means that all 6 of these items are going to be a 0.125 in thickness. Now, let's say that this 6x isn't really your cup of tea because that's a bit confusing. You might read that as 6.25 inches, or you might end up reading that as something even worse. You might say, oh, 6 times 0.25. That means that you need this to be 1.50 inches thick, and that won't be any good. So I'm going to give you an alternative for how you would do this by going into here again. And so what I'm going to do is get rid of this 6x and replace it with this, capital TYP. And then I'm going to go here to R, to the radius. And then again, I'm going to hit TYP. And so what does TYP stand for? Well, this stands for typical. That means that for any one of these spokes, the typical thickness is going to be 0.25 inches. Same thing for here. The typical thickness is going to be 0.13, or well, actually, I'll say, I'm going to switch this to have 3 units, so it's a 0.125. This is going to be the typical radius for all of these internal fillets. So for any fillets that are part of this item, chances are that the typical radius, unless otherwise stated, is going to be 0.125. So for example, let's say that you're confused and there's another fillet over here. Let's say we have one giant fillet that ends up being 0.5 inches, just some huge giant swoop here. Well, what I would do is come here and click on it, and it would say R of 0.5. So we know that that radius is not the typical radius, which is 0.125, but we know this is the standard fillet. So hopefully that makes a bit of some sense. So next thing I'm going to do is just finish this stuff up. So I'm going to add this radius here. This is just the radius of this big giant circle. And what I can do is just sort of move this down here and create that invisible line for us. Not invisible, but that nice light dotted line there. So people understand that that is the radius of this circle, this rounded area here. And then finally, I'm going to, of course, add the radius of the circle here. Now you'll notice that I have a small section there. I don't know why that's not working. But you'll notice that I have a small little area in here that has this invisible, dashy line. And that seems a bit confusing. The reason that that's there is because that is actually not a dimension, but rather that this is demonstrating that we actually have, oh, I don't know why that's there, that we have something that is tapped. So you actually have, this is where a screw is going to go. Sorry, there we go. This is also 0.125. Oh, there we are. And so you're going to get a tap. When this is 3D printed, you're going to get a tap and die kit and make sure that this is fit for a 1/4 bolt to go through it. And so the way we're going to do that is simply by editing this again. So we're going to go here and we're going to say, well, this is, if it'll load, it seems to be stuck right now. There we go. This is going to be threaded for 20 bolts. There we are. And now this annotation here is going to let us know what piece of information? Well, this is threaded for a 1/4 bolt. And then another good thing to do is make sure that all of this stuff is sort of annotated appropriately and moved to a space where it's not really obstructing anything. So I'm going to actually go ahead and move this over a little bit. I'm going to grab it here in the corner, try and hit escape, and then I'm going to grab this and move it over a bit. There we are. And that way I can move this to a place where it's not touching anything. People understand what that looks like. Another thing that I might add that I'm not going to do now, simply because it would take up a lot of time, is make sure that all of these dimensions are standardized. You can go ahead and edit that in. Usually you can edit that in the properties of the file and just change the standard for the entire part. So for example, this would end up reading as 0.125, but that's that would take a bit of time for me. So I'm going to go ahead and ignore that. I will include it in the last episode if it is needed, but otherwise I'll exclude it. All right, the next thing I'm going to do is just finish adding all this information here. All right, and then we are done. We have all of the things that we need for this part to be constructed. And another thing that we would usually do is go over here to the notes, and of course to say, all right, what we're going to do is make sure that we do all of this stuff. So you would describe the manufacturing process. So you'd say, you'd usually give something like the tolerances for this information. So the tolerances are going to say how you would want this to be fitted. So for example, if I were cutting this on something like a lathe, I would want to make sure that I state that I don't want this to be, I would want this to be greater than 5 inches, but it can be less than 5 inches by a certain tolerance that I state. So maybe that would be 0.01 inches, so 1/100th of an inch, which is pretty normal. But since this is going to be 3D printed, I won't do that. All right, and deburr sharp edges and corners as needed. Usually, again, that would be with something that's being made out of aluminum or another material, not necessarily something that's going to be 3D printed. All right, so we seem to have all of this information written down, and this seems honestly like a pretty good sketch. You might want to increase the size of all of these indicators here, but I'll leave that up to you as well. I think I might also just be zoomed out of it. The last thing that I want to talk about is this small little title card right here. Why is that important? And the reason that's important is because that's going to tell us all of the information that we need. So I can actually go here into my file properties. I go down here to iProperties, and then all this project information is going to come from the iProperties. So this is called wheel. I don't know why that is, but it's part number. Usually that'd be some sort of stock. So I'm going to call this. Autodesk part ADP. I'm going to call that 01 because that's the first file that I made for this project. And then I'll lowercase underscore wheel. And that's what I'll call it for now. Stock number. This is usually something that you buy. Description. This is the sample of the 4 wheels that will be used on our vehicle. There we go. Oops, let me spell that. Revision number. This is the first revision. Project. This is the greater project that it belongs to. In this case, it's going to be Gravity Vehicle. Designer is Cruzes. That's my username. I mentioned it, Cruz Soda. Engineer. This is just going to be the person who engineered this product, which is also myself. Fantastic. Oh, the person who would be manufacturing it. And the authority, but that's not really that important. Cost center, blah, blah, blah. All this stuff. Vendor web link, on and on and on. And then more importantly, the summary section. So this is going to be most of the information that's going to be in here. So the title is going to be wheel. This part 1. Subject. This is going to be just simply the 3D print wheel. Information, category, keywords, comments. These are all optional, more or less. I'm going to apply there. And as you can see, this updated to ADP wheel, that'll be revision 1. And then it added all the information, all of my information in here. And then the title here, wheel ADP 01. So that's pretty much it for Autodesk Inventor in terms of using these drawings, except for one last thing that I wanted to add. And if you remember correctly, from our 7th episode where we talked about assemblies, I said that, sorry, not assemblies, presentations. I said that presentations could be important in these projects. And the reason I said that is actually because if I were to go and exit and open a new project, and go ahead and save that, and I go to a new drawing, what I can do is create what's called an assembly drawing. And like you would expect, an assembly drawing is simply a drawing that has an assembly. But the difference is that you're not going to use the assembly drawing to have this crazy layout where you give the dimensions of every single part in your car, because that's very overwhelming. Generally speaking, an assembly drawing is going to be something that you use simply to communicate how something is set up, and almost always use an exploded view. I'm simply going to demonstrate, hopefully if this loads, I'm going to demonstrate how you would import a presentation as part of an assembly drawing so that you can show just what your assembly is going to look like as a whole. Just a good force of habit. All right, so as you can see, we're inside of another drawing. I'm just going to go ahead and demonstrate how you would want to create something like a assembly drawing. I'm not going to go through the whole process of defining this to be ANSI A. That would take a bit long. So instead, what I'm going to do is just sort of have this explosion here, this presentation, and then put that there. I want to view this usually from the top or somewhere where you can see all of this stuff exposed. I'm going to make this 2/3, actually 3/4, be more like it. Oh, that's not right. That's 3.4, not 3/4. 3.4. There we are. That's a bit better. And as you can see, you have a nice exploded view here that you can view. And then you can also import the main assembly itself. Go add the actual assembly. There we are. View from the top. Turn it. I want it this way should be fine. All right. And then we can have it, of course, with the same standard as the other one. What I would recommend is usually just having a wireframe of the actual assembly. Delete this view over here. So have the actual assembly, and then usually you would want to import something like what we had already, the exploded view, except you want to import an isometric version of the exploded view. So you have this here. I would probably want to view this from a little bit higher. And there we are. So we have this view here. Nope. You know what? Let's go back to the way it was imported. All right. There we are. Go back to this. Sorry. So that's the way that it came. I apologize for that. But essentially just import this view. You'd most likely want to make it bigger. And also on top of making it bigger, you'd want to have it in the actual rasterized view as opposed to having it in this odd wireframe view. So I'm going to make that again, 3/4. And there we are. All right. So this is how roughly you would want to have an assembly drawing. Usually you'd probably want to have a projected view of this. Here I'm going to add a projected view. Create this here. There we are. Oh, you want to have a projected view. That's not working for some odd reason. But you would want to have a projected view of this drawing here. There we are. Sorry. Create. There we go. And you want to have a projected view of your drawing. It's a little lopsided, again, because we were actually simulating the motion, if you remember, when we had our assemblies presentation all the way back in episode 6. But if you were to go ahead and fix that, it would appear straight and you'd be able to see the general way that your assembly is going to be designed. You'd also have a title here somewhere as well, but we usually do or do not do that. And that's usually included in a much larger title card right here. All right, so I hope that was something that everyone enjoyed. Again, tune in for our final episode very soon, and best of luck with the rest of the season.